Welcome to day 16 of Math 111. Today we're going to be working with operations with base 10 blocks. This will be similar to the operations we've performed in other bases in a previous lesson. We're working with base 10, so 10 units will equal 1 rod, 10 rods will equal 1 flat, 10 flats will equal 1 cube. We will remember this when we are trading up or trading down. You see here a picture. This shows your elements in a base 10 block kit. You see the cube, the flat, the rod, and the unit. When modeling addition, build both add-ins, and trade up is necessary. When modeling subtraction, build only the menu end, and trade down is necessary. Here is an addition problem. 437 plus 687. Notice that I have built both add-ins. The first add-in, 437, is modeled with 4 flats, 3 rods, and 7 units. 687 is modeled with 6 flats, 8 rods, and 7 units. When we get 10 units, we trade up for a rod. You can see that the trade has been made in the picture on the right. 10 rods are traded for 1 flat. You can see that this trade has been made in the picture on the right. 10 flats are traded for 1 cube. You can see that the trade has been made in the picture on the right. After all trades have been completed, you can determine the sum. The sum is 1,124. When you draw this on paper, this is the way it should look. Remember to draw both add-ins. Draw the model for 437 and also for 687. To show a trade, remember you circle your elements and draw an arrow to the element that you are replacing them with. So here we are trading up. We're trading 10 units for 1 rod. You can see that the rod has been drawn in the picture on the right, and an arrow has been drawn to it. We circle 10 rods and trade up for a flat. You can see the arrow drawn to the new flat. 10 flats are traded up for a cube. You can see how we have circled 10 flats and drawn an arrow to the cube. As a reminder, it does not matter which elements you circle. Circle the ones that are most convenient for you when you are making the trade. Here's a subtraction problem using base 10 blocks. 1,224 minus 386. With subtraction, remember that we build only the menu end. You can see there the representation for 1,224 using 1 cube, 2 flats, 2 rods, and 4 units. We're taking away 386. First of all, we want to take away 6 units. Since we do not have 6 units, we trade down. 1 rod is traded down for 10 units. You can see in the picture on the right that the trade has been made. After the trade has been completed, you are free to take away 6 units. The picture on the right shows that 6 units have been removed. We now need to take away 8 rods. There's only 1 rod, so we trade down. A flat is traded down for 10 rods. You can see in the picture on the right that the trade has been completed. We now want to take away 8 rods. The picture on the right shows that 8 rods have been removed. We now want to take away 3 flats. There's only 1 flat. We trade down again. The cube is traded for 10 flats, and you can see this trade has been made in the picture on the right. We're now free to take away 3 flats. And you can see that the 3 flats have been removed in the picture on the right. After we have completed the subtraction, the difference is left. We're left with 8 flats, 3 rods, and 8 units. Our difference, therefore, is 838. When you draw this on paper, remember you draw only the minuend. We draw the representation for 1,224. Notice that that is drawn in the picture on the left. In order to subtract 386, we have to perform some trading. Notice that whenever I trade 1 rod for 10 units, I circle the rod and draw an arrow to the 10 units that I have drawn there. When I take away something, I draw a circle around it and draw an arrow to the edge of the page. So when I'm taking away 6 units, I circle them and draw an arrow to the edge of the page. I make all of my trades like this, and when I take away elements, I circle them and draw an arrow to the edge of the page. The difference is the uncircled elements in your diagram. You'll notice that there are 8 flats uncircled, 3 rods, and 8 units. The difference is 838. We did not talk about multiplication and division when we were working with other bases. We will explore multiplication and division in the lesson today. In modeling multiplication with base 10 blocks, we will use the rectangular area model. We're going to use flats and rods to begin our array, and then we use flats, rods, and units to fill in the rectangle once we have the beginning. I'll show you in the next example. We want to multiply 17 and 13. I'll begin by forming a rectangle by laying out flats and rods. The edge of a flat is 10 units, and the narrow end of a rod is 1 unit. So if you count down the left side in the picture there, you'll notice that I have 10 and 7. That's 17. Counting across the top, again, the edge of the flat is 10 units, and the narrow end of each rod is 1 unit. So I have 10 plus 3, which is 13. This begins the rectangle with dimensions 17 and 13. The next thing to do is fill in the rectangle with the largest possible pieces from the base 10 kit. You'll notice that no rods will fit, but I can complete the rectangle by filling in with units. It required 21 units to fill in and complete the rectangle. If you count all of the base 10 blocks there, you'll notice there's 1 flat, 10 rods, and 21 units. The next thing is to trade up as necessary. Since I have 21 units, I can trade 10 units for a rod. You can see in the picture on the right that I have gained 2 more rods because I had 2 groups of 10. Now I trade up. 10 rods will be traded for a flat. You can see that in the picture on the right. After completing all trades, then my product is evident. I have 2 flats, 2 rods, and 1 unit. So the product is 221. Let's look at another multiplication problem. This time we want to multiply 23 by 34. We will again begin with a rectangle. My first factor is 23. So I will be using 2 flats and 3 rods down the side, as you can see in the picture. Remember, the edge of each flat is 10 units. So I have 10, 10, and 3. And to make 34, I will need 3 10s and 4 1s. So I have 3 flats across the top and 4 rods. Next, I want to fill in with the largest possible base 10 blocks. This time I can complete the rectangle using flats, rods, and units. If you count, you'll see that there are 6 flats, 17 rods, and 12 units. I'm going to rearrange these so I can start trading. We'll trade up 10 units for 1 rod. You can see that the trade has been made in the picture on the right. And now I'm going to trade up again. 10 rods will be traded up for 1 flat. You can see that the trade has been made in the picture on the right. After all trades have been completed, the product is evident. There are 7 flats, 8 rods, and 2 units. The product is 782. In modeling by division, we'll use the division by sharing model. We will build a dividend with base 10 blocks, and then we will divide into the prescribed number of piles. We will trade down as necessary. This first problem, 636 divided by 3. We begin by building the dividend. I've laid out 6 flats, 3 rods, and 6 units. I want to divide by 3, so I will start dividing into 3 piles. I'll begin with the flats. The 3 flats can be distributed evenly into 3 piles by putting 2 in each pile. Next, I distribute the rods. And the rods also can be distributed evenly into the 3 piles. 1 rod goes into each pile. Finally, I distribute the units into 3 piles. The units can be distributed evenly into the 3 piles by putting 2 units in each pile. The quotient can now be determined. The contents of one of the piles will be the quotient. The quotient is 212. Notice that there are 2 flats, 1 rod, and 2 units in each pile. Let's look at another example. 477 divided by 3. We begin by building the dividend. We lay out 4 flats, 7 rods, and 7 units. I want to make 3 piles. There are 4 flats. When making 3 piles, I put 1 flat in each pile, and there's 1 flat left over. I will trade down. The flat will be converted into 10 rods. I now have 17 rods. I want to distribute them as evenly as possible in the 3 piles. I can put 5 rods in each pile, but 2 rods are left over. I will trade down again. Each rod will be traded down for 10 units. You can see in the picture on the right that the rods have been traded. There are now 27 units. The units will be distributed evenly into 3 piles. I can do that by putting 9 in each pile, and there are none left over. The quotient can now be determined. Look at the contents of one pile. There will be 1 flat there, 5 rods, and 9 units. The quotient is 159. Let's look at another division problem. 477 divided by 4. This time we'll make 4 piles because the divisor is 4. The flats can be distributed evenly into 4 piles. 1 flat will go in each pile. Next, I want to distribute the rods. There are 7 rods. 1 rod can go in each pile. 3 rods will be left over. Those rods will be traded down for units. In the picture on the right, you'll notice that the rods have been traded down for units. There are now 37 units. I want to distribute them evenly among the 4 piles. I distributed the units among the 4 piles, and 1 unit is left over. The quotient can now be determined by counting the contents of 1 pile. The quotient is 119. The 1 unit that's left over is the remainder. So when 477 is divided by 4, the quotient is 119 with a remainder of 1. Let's look at one more example. 1,000 divided by 3. When I build the dividend, I just have 1 cube. In order to divide by 3 and divide this into 3 piles, I will need to trade down. The cube is traded down for 10 flats. The flats are divided into 3 piles. 3 flats go in each pile, and 1 flat is left over. I trade down again. The flat is traded down for 10 rods. And the rods are distributed among the 3 piles. 3 rods go in each pile, and 1 rod is left over. I trade down again. The rod is traded down for 10 units. The 10 units are divided equally among the 3 piles. 3 units go in each pile, and 1 unit is left over. We can now see that the quotient is 333 because there are 3 flats, 3 rods, and 3 units in each pile, and there's a remainder of 1. 1,000 divided by 3 leaves a quotient of 333 with a remainder of 1. You need to practice drawing models for addition, subtraction, and multiplication with base 10 blocks. The practice will help you understand the ideas of carrying in addition and borrowing with subtraction in the area model for multiplication.